This video is going to be on rational graphs for pre-calculus class. You should be getting a form that looks like this to help follow along. So as I label these, the vertical asymptote will be number 1. Okay, vertical asymptote will be number 1. Horizontal or slant will be number 2. All right, the hole will be number 3. The x-intercept will be number 4. The y-intercept will be number 5. The domain will be number 6. And the range would be number 7. Okay? So in the interest, let me make sure that looks okay on the camera. Yeah, in the interest of just space and whatnot, that's what we're going to have. Okay, so what you can do is you can put these examples down. I'm going to go through, we've laid a little bit of the groundwork for rationals. Okay, want to go through some more examples here. Okay, so you can put this example as the first one down. Okay, you can copy that one down. I'm going to show you how to find all these. All right. Now, you have to factor or eliminate factors. So as you can see, I can eliminate that. Okay. All right. So, what that's going to be, that eliminated factor, if I solve that, that would be x equals -3 would be the solution. That will be the whole. Okay. We'll get to plot the whole in a second. So what you have now is a leftover function is this. Okay? Now, what we're going to do, we're going to find the vertical asymptote first. The way we find the vertical asymptote is we solve the denominator. So that one would be x equals 4. So my vertical asymptote would be x equals 4. To get the horizontal or the slant, I have to look at the situation. If the exponent is bigger than the denominator, for instance, x is bigger than a coefficient, then that's going to be automatically a horizontal asymptote of y equals 0. Okay? All right? X-intercept, what I'll do for that is I can go into the graph. I'm going to graph what I have left over. Parentheses around the top part. Parentheses around the bottom. That saves you from making mistakes. Okay? G-solve root. Okay, so it didn't have one. G-solve y-intercept. Y equals -0.25. Okay, now I can graph this and find the domain and range. Okay, so we graph all these things. A vertical asymptote at 4. A horizontal asymptote at 0. A hole at -3. What you can do is you go back into the menu and go to table. Your function's already in there. You might have to hit select, which is F1. But if you hit table, okay, and you type in -3 for where the hole was, it will tell you where that's at. -3, -0.1. It's like right there, somewhere in there. Okay, so that's how you graph the hole. The y-intercept would be here, okay? And then if you look at the curves, okay, in the graph, all right, you can see that the curves are going to go here. Only picky about that it goes through the asymptotes and the intercepts and the holes. Okay, all right. Let's do another example. Oh, the domain. The domain would be everything except the following things: the hole and the asymptote. So there's a couple different ways you could write that. You could do, x is an element of all real numbers. okay? Except x can't be 4, x can't be -3. Another way you could do that is just go negative infinity to -3, union -3 to 4, union 4 to infinity. This might be the easier way to do that. The range is going to be all real numbers, except y can't be 0, where my horizontal asymptote is. Okay? All right, let's do another example. Let's say this were my function. Okay, let's say this were my function. What I would do is I would factor the denominator. And I would figure out that those two things eliminated. Okay, that's going to be my whole. Okay, so 1 vertical asymptote, 2 horizontal asymptote or slant, 3 whole. Whole will be x equals -1. X-intercept, Y-intercept, domain, and range. Okay? My vertical asymptote is going to be x equals -6. Okay, my horizontal asymptote, since the x is bigger than that, would be y equals 0. Looks like, all right, G solve root, there is none. G solve y-intercept, y is 0.16. So I graph all that stuff, vertical at -6. Horizontal at 0. A whole at -1. Oops. Sometimes that happens, make sure you hit select. -1 is at -1 and 0.2. Okay. Y-intercept at 0.16. So if you look at the curves, okay. Goes a little bit like that. Okay. All right, let's move on to a couple other examples. Let's say I had something like this. All right, I can't factor anything here. My vertical asymptote will just be x equals 3. My horizontal asymptote, since I have a tie, I would divide those numbers. 4 divided by 1 would be 4. Okay, whole, I don't have one there. Okay, x-intercept, y-intercept. Oh, I forgot to do the domain and range for this one. All right, my domain, x is an element of all real numbers. All right, but x can't be, the things x can't be is -6. X can't be -1. The range would be y is an element of all real numbers, but y can't be 0. Okay. All right. Domain and range. 1 divided by x minus 3. Okay? G solve root, I got x equals negative 0.25. G solve y-intercept, y equals negative 0.3 repeating. Okay? So the way that would be graphed, x is 3, horizontal asymptote 4. Okay? There is no hole. X-intercept at negative 0.5, something here. Y-intercept at negative 0.3, which would be about here. Okay? If you look at the curves, one curve would go through that. And another curve would go through that. The domain would be x is an element of all real numbers. X can't be 3. Range would be y is an element of all numbers. Y can't be 4. Okay? All right. Here's our next example. I would have 2x squared minus 7x minus 4 all over x squared minus 2x minus 8. Okay? Same stuff over here. So what I would do is factor this, and this is the way this one would end up factoring. I would end up factoring like that. Let me make sure you can see that on the camera. Yeah, barely, but you can see it. Okay. So these would eliminate, making that whole x equals 4. So the factor is x minus 4, that would be the solution. What's left over now is this. So we got ourselves a tie. So if I divide the numbers out front, I would get y is 2 as the horizontal. Okay, I solve the denominator, so that'd be x equals negative 2 would be the vertical asymptote. Okay, I graph what's left over. Okay, I get that kind of picture. G solve root, x equals negative 0.5, which would be like right here. G solve y-intercept, y is 0.5, which would be like right here. Okay, the vertical asymptote at x equals negative 2, horizontal at 2. Okay, a hole at 4. So once again, I go into the table. Hit select table. I put 4 in there. It's 4 and 1.5. 1.5 would be about here. That's your hole. Okay, so that your curves would go through this. The curve would be over here. The domain would be x is an element of all real numbers. X can't be negative 2, x can't be 4. My range, all real numbers, y can't be 2. Okay? So basically the domain can't be the hole, can't be the vertical asymptote, the range can't be the horizontal asymptote. Okay? All right, now we're going to move on to the ones involving the slant asymptotes, which these ones are probably the ones that are going to take a little bit more work for you guys. Okay, but I want to go over a couple of examples here of how to do the slant asymptote. Okay, so let's say this is your function. All right, so you're like, okay, first thing I notice is that this is bigger than this, so I'm going to have a slant. So I'm a vertical, I'm going to have a slant asymptote. All right, I'll check for holes. X-intercepts, Y-intercepts, okay, obviously domain and range. Let's see how this factors. Now when I factor in it, it's really this, and as you see, nothing eliminates, so I can really just use this component here. So my vertical still is 3, okay? Now let's discuss how you get the slant asymptote. What you're going to do is we're going to do polynomial division, the long division that we did in the previous unit. So that would have to be x squared, and negative 3x. So I would put minuses here. Negative 7 minus negative 3 would be negative 4x. So that would be negative 4. Negative 4x and 12. That would be 2. That would be the remainder, 2 over x minus 3. Now, that would be the polynomial division. The most important part of that is the non-remainder part. That will be the equation of our slant asymptote. Okay, of x minus 4. Now I'm going to erase this so I can, all right, I'll show you how that basically all comes into play. Okay, there is no hole, okay. So I'm going to graph it, parentheses around the top, x squared minus 7x plus 10 divided by x minus 3. Here's what it looks like. As you can see, a little bit different in the shape of the graph, okay, than the other one. Okay. So, let's get those intercepts. One intercept is 2, and one intercept, 2 and 5, sorry. Y-intercept is y equals negative 0.3 repeating. Okay. So nothing changes as far as how we get this. Nothing changes. Well, I'll get back to the hole in a second. X-intercept being at 2 and at 5. Okay. Y-intercept at negative 3.3. Okay. Now, all right, the way the equation x minus 4 works is this would be, if I did plotting a line, I start at the y-intercept, which is negative 4, I go right one, I go up one, right one, and that would create a slant asymptote. Okay, and I'm gonna tie this into your picture, okay, and how this looks. Okay, so basically, what's gonna happen is this picture's gonna go here, boom, and then wide that way, and then this one, and wide that way, okay? So that's why you see that space in between. So you plot the line, 1x minus 4, and that helps you get that, all right? Your domain is all real numbers, except x can't be, okay? X can't be 3, okay? I think that's it, actually, there's no hole in that. Okay, and then your range is, y is an element of all real numbers, okay? Now, as you can see, all right, there was no horizontal asymptote. So, really, this thing is going on forever in this direction, this direction. So, it's really it's just all real numbers for the slant asymptote there, okay? All right, let's go on to another. I'll do one more slant asymptote question, because I know those ones are the most challenging. Let's say I had 2x squared minus 7x plus 6 all over x plus 1. Okay? Now if I factor this, this is what I end up getting. Alright, so as you can see, okay, no elimination, so that's bigger, so my vertical asymptote, so the idea is I'd solve that x equals -1. Or I'm going to have a slant in this case. Okay, let's figure out our slant asymptote. Okay, let's see, can you see that with the camera angle? Let me see. I'll probably have to do that in the middle again. Two x, it's going to be 2x squared plus 2x minus minus, that'll be -9x plus 6 minus 9. It ends up being 15, okay, over x plus 1. So my slant asymptote will be 2x minus 9, okay? I can graph it, help me find the other stuff too. Oh. Okay. All right. So G solve root. I got an x-intercept of 1.5. G-solve y-intercept. Y-intercept is 6. Alright, there was no hole. Okay, as we done. Main range. Okay, vertical asymptote at -1. Okay, slant asymptote at 2x minus 9. So that means I go right to 1. I wonder if I keep zooming out whether I'd see that other part. Yeah, there it is. So it's in between there. Okay, so that other one's down all the way in here. This one, if I plotted 1.5, then plotted 6, we'll do something like this, okay? All right. So that domain is going to be all real numbers, except x can't be -1. The range is all real numbers altogether. Okay, it covers the whole shooting match. Okay, you can look at minimums and maximums. There's less concern about the domain and range on the slant asymptotes. So now you'll have some of these to practice on your own. Use this video to help you.